ANSYS Simulation Lecture 9, Linear Buckling Analysis. First of all, load the software and then enter ANSYS Workbench. ANSYS requires that you run static analysis and buckling analysis in series mode. So once you get in project schematic environment, we will drag structure analysis and drop on geometry, and then drag linear buckling analysis and drop on the solution tab of structure analysis. So the result of static structure analysis will be fed into linear buckling analysis as a pre-stress condition. So now I'll edit the material and I'll choose a material that is a polyethylene material and go back to project, and I'll enter ANSYS mechanical environment by editing model. And once we enter ANSYS mechanical environment, first thing we should do is to connect or link the material with the geometry. So I'll find the geometry and link it with the material. So I have finished with the first and second step of CAE analysis. The first one is geometry and the second one is the material, and I choose polyethylene, which is the right material for toys. So I will update the mesh. And then for step 4, in the static structure analysis, I will fix the bottom surfaces. I'll zoom in a little bit and choose the 4 surfaces. Okay, these are the 4 surfaces that I will fix. And then for the loading, I'll choose concentrate load and on the top surface and with a magnitude of 1, and be very careful with the direction. The direction must be on compression direction, so make sure that the load is in compression direction. So this is the surface of load and direction of the load, and the magnitude will be 1 Newton. And now I'll solve for the statics analysis. Don't push button here, because once you solve here, both procedures will be implemented. So now we can only solve here by right-click the mouse on the solution tab of static structure. So it won't proceed with the linear buckling solution. So now I have finished with the static structure analysis, and the result seems to be right. So now I'll enter linear buckling analysis, and the pre-stress condition is already here. So I'll go ahead and define how many modes I'll calculate. And actually you only need one lowest load to collapse the structure. So the default is often 1, but you can enter a higher number so you can look at a higher mode of failure. So now we can assign the total deformation to be the result and solve for buckling. And then we get the lowest buckling load, which is 8229 Newton. So it is about 320 kilograms of load in order to collapse this chair. And in the buckling analysis, the support is very important if you loosen some of the support, the buckling load will be reduced. The lowest buckling load will be reduced. So when you design a structure, make sure that the support is securely fixed, because loosen the support will mean a lower buckling load, and it will collapse at a lower load. So this is lecture 9, a linear buckling analysis in ANSYS environment.